Hi, this is Dr. Khan Khattak. Welcome to another lecture on international business. In this session, I'll try and analyze how the issue of global chip shortage is causing headache for different industries, including the automobiles, and the threat it poses to the notion of globalization. Also, we'll investigate how the same issue refutes the existing theories of international trade and comparative advantage. As we all know, chips slash semiconductors are something very difficult to avoid in this modern day and age because they power almost every electronic item that we buy and use today. From smartphones to laptops to computers to fighter jets, you find semiconductors or chips in all of these gadgets. But the problem is that these chips or semiconductors are not being produced in enough quantities, which is posing a serious threat to the production and sales of different products or industries, especially the automobiles. As we all know, automobiles are becoming increasingly electronic, and electronics constitute about 40% of the value of cars. According to some experts, about 1400 chips are used in smart cars these days, and these cars have essentially become computers on wheels. The chips that are used in cars power countless functions in cars, from the very basic ones to the very advanced ones. The basic ones include power steering and power brake system, whereas the advanced ones include the running of the electronic engine system, electronic transmission, the powering of infotainment and navigation systems. However, in the wake of the massive global chip shortage, few of the world's largest automobiles manufacturers such as GM and Ford had to close down production for its crossovers and cars in North America. As you can see on the screen, GM closed down its North American plants in Kansas, Mexico, and Ontario. Whereas Ford also had to pull brakes on the production of its F-150 trucks produced in North America. According to Morgan Stanley, all these closure of plants due to unavailability of chips could lead to 1.5 million fewer cars made this year, and this could translate to about $60 billion loss of revenue for the auto sector. In order to better appreciate the issue of chip shortage, first we need to understand what chips or semiconductors are and how its industry or supply chain is structured. Chips are essentially the brain of the smartphone or the computer with which you are watching this video perhaps, and these are silicon wafers which has countless of these pin-shaped elements called transistors packed onto it. A transistor is a kind of semiconductor which was first successfully discovered in 1947 at Bell Labs in New Jersey, and its inventor basically won the Nobel Prize for physics, and they founded the first tech company in Silicon and thus laid the foundation for today's modern digital world. Historically, engineers could pack about thousands of transistors onto one chip. However, with the passage of time over the years, engineers or semiconductors companies can now pack or mount about billions of transistors onto one chip. And that's why its size is measured in nanometer, and nano being the billionth part of a meter. So the efficacy of chips is measured in terms of how smaller, thinner, and faster they are these days. Here are the pictures of some 5 nanometer chips designed by the leading computer and smartphone companies from all over the world. A14 Bionic was designed by Apple, and it contains about 11.3 billion transistors, and this chip has been assembled into iPhone 12. Whereas Kirin 9000 is supposed to be the smallest and fastest chip ever produced by Huawei. Rather, it was designed by its subsidiary called HiSilicon, and this chip contains about 15.3 billion transistors. And this chip has been assembled into one of the latest smartphones from Huawei called Mate 40. Similarly, Samsung has the latest chip called Exynos 2100, and this has been assembled into latest Samsung tablets and smartphones. Remember, some of these chips are only designed by these companies, such as Kirin 9000 was designed by HiSilicon, which is a subsidiary of Huawei. However, its manufacturing was done in Taiwan by a Taiwanese company called TSMC. So similarly, A14 was only designed by Apple, whereas its production happened in Taiwan by a Taiwanese company called TSMC. Now, remember, as per industry parlance, all the chips having a size of 7 nanometer and below, for example 7 nanometer, 5 nanometer and 3 nanometer, 2 nanometer, these chips are considered to be the leading edge or cutting edge or advanced chips as per the industry terminology jargon, whereas the chips having a size of 7 nanometer, above the size of 7 nanometer, for example 10 nanometer or 14, 28, 45, these chips are considered to be less advanced or otherwise called legacy chips. So the question is, why is it important for chips to get smaller and smaller? In order to give you an idea on the perspective of the size, today's or 5 nanometer chip produced by TSMC can house as many features as it was otherwise possible with 14 nanometer chip designed by, for example, Intel or elsewhere. So today's 5 nanometer chip can house, for example, CPU, GPU, cache, or machine accelerators, and for specialized units for audio and video, and of course it also has a provision for cryptographic security. So in terms of functionalities and possibilities, 5 nanometer chip can house as many functions as otherwise was possible with 14 nanometer chip. The typical supply chain or value chain of semiconductor industry comprise of three main functions, which are carried out by three major types of companies called design companies, fabrication companies, and assembly and testing companies, also known as OSAT, outsourced semiconductor assembly and testing companies. The companies that design the chips basically design them on computers, and this is typically done in offices. You don't need manufacturing facilities for designing chips. And most of these chip design companies are concentrated in the US, and they are Qualcomm, Nvidia, Apple, Amazon. So these companies basically first design these chips with the help of EDA tools, which means electronic design and automation tools. These are softwares which is also controlled by the US. And the two leading companies, EDA companies from the US, are Cadence and Synopsys, and there's another one called Mentor Graphics, which is owned by Siemens. So EDA companies are also concentrated in the US, and they typically provide the software which helps in designing these chips. Once the chips are designed by Nvidia or Qualcomm, they are sent for manufacturing to the fabrication plants, also called foundries, and these foundries are typically concentrated basically in Asia, one in Taiwan called TSMC and the other is in South Korea called Samsung. So these two are the leading foundries which basically manufacture the leading nodes or the leading processors or leading chips having a size of less than 10 nanometer, meaning it includes chips sized 7 nanometer, 5, 3 and below. Whereas the mature nodes, of course, are also manufactured elsewhere in the world. For example, China is also included in this. Apart from Taiwan and South Korea, China is also manufactures chips which are sized above 10 nanometer, because that doesn't need much of advanced technology. But remember this, in order to manufacture these leading nodes, meaning smallest chips, you need a lithographic machine. So 10 nanometer and above chips are actually manufactured with the help of DUV machines, DUV, deep ultraviolet lithographic machine. So these are not that advanced, they are less advanced. But the manufacturing of these equipment and tools is also controlled by one company in Netherlands called ASML. So these lithographic machines are controlled by a company called ASML, which is in Netherlands. Whereas for manufacturing advanced chips or leading nodes having a size of 7 nanometer and below, you need EUV machines or extreme ultraviolet lithography machines. Of course, that is also controlled. So ASML enjoys kind of monopoly in terms of manufacturing equipment which is needed for manufacturing of advanced or leading edge chips. And when it comes to, of course, designing of the chips, EDA tools, there the US and Germany enjoys kind of monopoly on the software tools. And there are those companies at the end which are called basically OSAT companies. They package and test and assemble and test these packages into different products. They are also concentrated, most of these OSAT companies are also concentrated in in Asia, of course, and the leading one being Foxconn, which basically packages the chips for Apple, of course, the leading computer company called Apple. So remember, design companies, which are called fabless companies. I mean, I can give you an example. Like Apple designed its soft processor called M1, but this was only designed by Apple. Wasn't This was never manufactured by Apple. For manufacturing, it was sent to Taiwan, to TSMC, of course. Similarly, A14 Bionic, which is used in the smartphones, which is the smallest and fastest chip, which was designed by Apple. That was also designed by Apple, but wasn't manufactured by Apple. That in fact was manufactured by TSMC in Taiwan. So, as I said, but there is another type of companies which basically perform both of these functions, design and manufacturing, or foundries. These are called integrated device manufacturer. They're called IDMs. Typically, Intel and Samsung falls in this category. So, ITM used to do back in 70s. They used to perform all the functions from design to manufacturing to selling these chips, or assembling these chips into different products. So IDMs perform both the function. They are vertically integrated basically. But this trend changed, as you know, in the 70s up until 90s. Most of the companies in the US were IDMs. They would perform all the function through the value chain, from designing of the chips to manufacturing to assembly and testing all the. But this trend changed, with the advent, or with the surge of globalization. As you know, now you're open to produce your product anywhere it is cheaper, and competitive, cheaper and of better quality. So of course you're allowed to take your manufacturing facility anywhere. So after 90s, this trend changed, so which significantly reduced the share of the US companies in the chip manufacturing. So US is now only dedicated to designing these chips instead of making them. So back in 90s, US used to produce about 40% of the chips, because most of the companies were IDMs, integrated device manufacturers. But now these companies have moved on to fabless model of chip designing and manufacturing. So similarly, when it comes to materials, of course, there are certain companies, but in terms of materials, normally silicons and gallium are used as materials for developing silicon wafers, or these chips. So most of the supply of these materials is controlled by China, and there's another company called JSR. Okay, here I would like to mention about this ARM architecture. When it comes to designing processes, there's two types of instruction set architecture. One is called RISC, which is reduced instruction set computing, and the other is called CISC. So ARM is a UK-based company basically, which designed these reduced instruction set computing processors. And CISC is complex instruction set. So RISC means it can perform a large number of relatively simple instructions. So normally small processors can handle huge amounts of instructions, but simpler instructions. So whereas CISC is normally used in desktop computers and laptops, which can handle small number of very complex instructions for completing a task. So CISC needs a bit of more transistors and more power, CISC processing, whereas RISC needs less power, less transistors, and it is less prone to heating. That's why RISC type of architecture is normally used in the processors used for iPhones, tablets, and smartphones and all that. So that's why ARM structure or architecture is basically used for smaller handheld devices or smartphones and all that. So RISC. So, but we need to remember this RISC designs, and the license of RISC is controlled by a company called ARM, which is Advanced RISC Machines company, which is based in the UK. So it controls its design. So it designs the architecture and then gives the license of the core designs to other companies. For example, HiSilicon in China, they can replicate those designs and can mount chips from those. So RISC you cannot run, and as you know, these days the apps made for CISC, meaning apps made for computers and laptops, do not run on RISC based processors which are used in smartphones and tablets and iPhones and all that. So you have to make note of that thing as well. Now, answering the question as to why this shortage happened in the first place, why most of the industries in the world are facing chip shortage or semiconductor shortage. Um, to answer this question effectively, I broke down the reasons into three different categories. I call them demand side factors or reasons for the shortage, supply side, and the geopolitical aspect of the shortage. The demand side factors have to do with the COVID-19 pandemic. You know, at the start of the pandemic back in 2020, most of you know, the consumer behavior changed significantly. This pandemic resulted into lockdowns, which changed the consumer behavior drastically. You know, most of the consumers, they did not eat out, they did not dine out, they spent less money on movie theaters outside, so they saved that money. So instead of spending that money on cars and other thing, they channeled that money buying more laptops, more computers, and upgrading their phones and smartphones and upgrading their home theaters and all that. So which basically produced an abnormal demand or significant demand for leading edge or advanced chips, because at the same time, even around the same time, 5G was also introduced. Internet of Thing is also becoming common. So these factors basically change consumer behavior. During the lockdown, our consumers, their behaviors changed a lot. We worked from home, so you know there was this concept called remote working. We played games at homes, you know, so that actually created a significant demand for leading edge technology products such as gaming consoles, or buying more laptops, more computers, more like 5G enabled devices or smartphones. And around the same time, as we know, 5G was also introduced. So this actually led to then the foundries were already, you know, were working at full capacity. So then foundries didn't have enough capacity to, you know, to accommodate the new orders coming from these new segments or new industries, of course. So and now and back in 2020, even in 2021, the lead time for the chip manufacturing was about 12 months, you know. So different, even PS5, PlayStation 5 from Sony was also getting delayed because of not getting enough chips on time. So as I said, so these demand side factors led to the abnormal or excessive demand for leading edge chips or cutting edge chips of size 7 nanometer, 5 nanometer and below. And also on the automobiles part, you know, they had inaccurate demand planning, because at the start of the pandemic, they estimated slowdown in their sales, and as a result, they canceled their orders with the chip manufacturers all over the world. However, you know, the demand surged back quickly, you know, because of the recovery of the East Asian economy. So East Asian economies recovered sooner than expected. So which created an abnormal and excessive demand for automobiles. So in these automobiles, companies including GM, Ford, and other, for example, Daimler, Mercedes, and Volkswagen, so they started putting orders back with these chip companies, but by then it was too late. So inaccurate demand planning also resulted in the in the chip shortage for automobile sector. But remember, the chips used in automobile sectors are less advanced ones. They're called legacy chips, and of course, but you know, these companies also. Another thing, post-COVID recovery and stimulus recovery plans, as you know, around the same time, in order to boost the economies, most of the countries in the world gave stimulus packages and lowered their interest rate, which also um, put money in the hands of the people, which and their purchasing power increased, and they started buying these new electronic gadgets, including gaming consoles and new and computers and internet and smartphones and all that. And then there are supply side factors. As I said, back in 70s, most of the companies were IDMs, integrated design device manufacturers, meaning they would perform all the three functions of chip manufacturing themselves, like Intel and all that. There's another company called Micron. So they would first design the chips, then manufacture, and then assemble them into different products or sell them. But that trend changed, you know, as I said, and most of the companies then just stuck to one aspect of manufacturing. They just stuck to designing. Most of the US companies became chip design companies, like I mentioned, Qualcomm, Nvidia, Amazon, Apple. Like M1 processor, I just gave an example. It is designed by Apple, but is not manufactured. Similarly, Snapdragon 5G chip 888 is designed by Qualcomm, but is not manufactured by Qualcomm, which is a US company. So the manufacturing happens in fact in Taiwan by TSMC. So this trend actually reduced the share of the US and the chip manufacturing from 40% in 1990 to just over 12% now. So now US manufactures just 12% of the chips, and whereas they consume about 47 to 50% of the chips produced in the world. So the other aspect is again increased reliance of American digital companies on foundries, as I just mentioned this. So most of the companies became design companies, and they or fabless companies, and they increased their reliance. Another thing happened was the fab companies, or fab mean foundries, of the companies that manufacture these chips, like TSMC and Samsung. They actually diverted their resources or their production lines from the less advanced chips used in automobiles to very advanced and leading edge chips, because the leading edge chips, though they only have 5% of the share in terms of volume, because most of the chips produced in the world are less advanced. About 90% of the chips produced in the world are less advanced on legacy chips sized above 10 nanometer, but their value is just very small, meaning they're not much expensive. So the margins or the profits lie in the higher end of the chips, which is the advanced ones, 5 nanometer and below. So as I said, these semiconductor companies like TSMC and Samsung, they diverted their attention to advanced one in order to reap, or in order to gather more profits, compared to concentrating on the less advanced segment of the market. Or here's the chart, which shows how these, the breakdown of the chip manufacturing in the world. So as we can see here clearly, that three leading companies: TSMC, which is from Taiwan; Samsung, which is from Korea; and UMC is also from Taiwan. So they control about, as you can see here, about 75% of the chip production in the world. So today, about 75% of the chip production takes place in East Asia, I would say, and we can call it like the market is kind of a duopoly, and the two leading companies which control two-thirds of the chip production are Samsung and TSMC. So it is kind of a duopoly situation. Only two companies are controlling the world supply of chips. Another major factor that contributed to the global chip shortage is the geopolitical tension between the two largest economies of the world, the US and the China. The US uses this non-market instrument called Entity List or Foreign Direct Product Rule. These lists basically include companies whose behaviors are found contrary to the national security interest and foreign policy interest of the US, and these companies are then denied access to the US. The companies which end up on these lists are denied access to US technology. So basically around mid 2020, the Trump's administration blacklisted two leading companies from China, Huawei and SMIC, and they included them on entity list, and asked American companies not to supply chip design and all that to these two leading companies, Huawei and SMIC, on the charges that Huawei and SMIC are connected to or associated with People's Liberation Army, or CCP, which is Chinese Communist Party, and they were also charged with the spying on the US, these two companies, Huawei. And so these two companies got blacklisted by the Trump's administration back in 2020, which also fueled to this shortage in a big way. There's another rule called Foreign Direct Product Rule, which actually um, asks non-US companies if they are using US technology. From ASML, which is a Netherlands-based company which manufactures the equipment used in chip manufacturing, but they basically use US technology. So any company in the world, in the universe, which uses US technology has to first apply to the US for getting an export license to the companies which are included in the entity list, meaning TSMC was basically manufacturing chips for Huawei, like I mentioned in one of the previous slides. That Kirin 9000 was designed by HiSilicon, and HiSilicon, of course, is a subsidiary of Huawei, whereas they would actually manufacture Kirin 9000, the smallest and fastest chip from Huawei, in TSMC Taiwan. So Taiwan cannot, of course, supply or manufacture chips for Huawei unless it gets permission from the US under the foreign direct product rule, meaning TSMC uses ASML equipment or EDA tools designed by of course Cadence and Synopsys, which are US companies. So TSMC cannot, of course, under foreign direct product rule supply. TSMC first has to apply for export license to the US and get permission for supplying or manufacturing chips to Huawei, because TSMC uses some US technology. So those companies which use US technology anywhere in the universe first has to seek permission from the US in order to supply uh, technology to the companies included in the entity list. So Huawei got denied from the manufacturing of the advanced chips from TSMC because TSMC uses a Taiwanese company, it uses US technology. Similarly, ASML also refused selling the advanced extreme ultraviolet lithographic machines for manufacturing of 5 nanometer and 7 nanometer chips to Huawei or to SMIC, Semiconductor Manufacturing International Corporation from China, because ASML also uses US technology for while developing machines for the advanced. Similarly, ARM manufacturers, HiSilicon, which was a subsidiary of Huawei, they would design advanced chips, but they would use EDA tools from the US. So HiSilicon also cannot design advanced chips anymore because um, the ARM company in the US also denied giving license for the risk-based architecture to a HiSilicon company, to a company called HiSilicon, which is a subsidiary of Huawei, because ARM also uses some of its technology from the US. So on these grounds, most of the companies were denied, when Chinese companies were denied access to the US technology, of course. And here, so in order to remedy this problem, in order to resolve the shortage of US of chips, so two leading economies, of course, US also ordered inquiry into the supply chain issues of the chip, and so Biden administration actually set up a committee, and they were asked to review the supply chain leakages, and they were given 100 days to review this thing. And also the Biden administration called a chip summit back in April, and where they actually decided to they invited Intel and Qualcomm and Nvidia and all that, and they asked them to go for domestic production of chips instead of relying on the supplies from supply chain from other countries. So they should manufacture these chips in house. Similarly, China is also in the wake of this US trade conflict, US-China trade conflict. China wants to achieve a self-sufficiency of 70%. Remember, right now China only produces 7% of the chips it uses. So out of $450 billion chips sold every year, about $350 billion chips are bought by Chinese, are used by Chinese. So Chinese only manufacture about 7% of these chips right now, but they want to increase their self-sufficiency, or they want to be independent, because they revealed their 5-year plan, and in their last 5-year plan, which was released just March this year, and they said they would like to achieve 70% self-sufficiency in terms when it comes to chip manufacturing and chip production. So as you can see, the two leading economies are moving away from globalization and becoming more of isolated uh, when it comes to chip production. So these initiatives from the two biggest administrations of the world, the US and the China's administration, are challenging are challenging the notion of globalization and the theories of comparative advantage. So as you can see, globalization wants economies to be interdependent, but now you can see America wants to be independent of China, and they want to produce chips in-house in the US, and that's why Intel announced $20 billion investment in a chip manufacturing facility just 2 months back. So they are building two large chip foundries, advanced chip manufacturing foundries in Arizona, of course. So, and IBM also came up just last week, I think they came up with the latest chip, 2 nanometer chip. So now you can tell these countries are moving away from interdependent supply chains to independent supply chain when it comes to. So they are posing a serious threat or serious challenge to the notion of globalization. So then, and at the same time, theories of comparative advantage advocate the countries which are good, which have a relative advantage in the production of something, they should specialize in that particular product. But that's not the case anymore, as you can see, because earlier on, previously, Belgium was good at, research and design of chips. Netherlands was good at developing chip manufacturing equipment, EUV and DUV machines, and chip designing was relegated to the USA. And chip manufacturing was done by Samsung and TSMC, was done mainly in Asia. Materials were supplied by China, but that thing is changing in a big way because now all China wants to do all the steps through the value chain in-house in China. They want to do all the steps from chip design to chip manufacturing to chip to OSAT facilities, outsource, semiconductor assembly and testing facilities. So all these moves and initiatives are causing or are giving a big dent, are creating a big dent on the notions of globalization and theories of comparative advantage. After having discussed so many things, I think we should now be able to answer these questions in order. The first question is discuss the geopolitics of semiconductors from the perspective, why has Joe Biden put semiconductor on his policy agenda? So as I just mentioned, the chips are posing a serious threat to the national security and foreign policy interest of the US. As you know, F-35 fighter jets cannot get enough chips if and F-35, which is the latest warplane manufactured by Lockheed Martin, has chips which are manufactured by TSMC in Taiwan. But Taiwan is under the influence of China, and China claims that Taiwan is an integral part of us, is an integral part of China, and anytime soon they might, get control over Taiwan, and of course can Chinese Communist Party can put their own members on the board of the TSMC and can control the supply of advanced or leading chips or nodes to some of the fighter jets of the US. So military might of the US would be seriously threatened or questioned if Taiwan comes under any attack from China and all that. So that's why Biden's administration is seriously looking into it, because there are two aspects of national security and economic security, and they have to see which security comes first. Is it if national security needs more importance, needs more preference, needs more attention? So of course they will they are ready to compromise some of the principles of economic security in order to in favor of US national security. So yes, chips are an integral part. They power every gadget in this modern day and age. So that's why Biden administration ordered a 100-day inquiry into the supply chain issues of chip shortage, and then resolved ultimately and announced a $50 billion package for in-house production or domestic production of chips in the US. Similarly, automobile companies are facing this temporary shortage of chip, of course, but they rely on the less advanced ones. And of course, should they rely on outsourcing? Yes, they should rely. They shouldn't go for manufacturing these chips on their own, because building a chip manufacturing facility needs about $5 to $6 billion of an investment. So and it takes about 3-4 years to build a chip manufacturing plant. So of course, that's not an easy job. So yes, at the moment, they should wait and see and let the situation calm down. So of course, by the mid of 2021, perhaps there'll be enough chips in the market. China, and again, as I said, if we paint the whole picture right now, China is leading, Asia is leading Taiwan and Samsung, because they're already producing 3 nanometer. They're already producing 5 nanometer chips. 3 nanometer chips have already been the pilot testing has already been done for 3 nanometer chips, which will be commercially available sometime next year. And TSMC has already built a plant in Taiwan, of course, in Tainan, Taiwan, of course. Whereas US is far behind when it comes to manufacturing leading edge chips. Intel can only manufacture up to 7 nanometer, and that would be into, whereas I mean countries in Asia are already producing 3 nanometer chips. So US, it will take about 5-6 years or a decade for the US companies to catch up with East Asian companies, I mean foundries, when it comes to manufacturing cutting edge chips. Uh, all right, that's it for now. If you found this video interesting, don't forget to like and share the video, and subscribe to my channel called Dr. Khan Khattak. See you in the next video. Thank you very much.